Now we are going to start the next permutation question. Let's read it. It's a medium level question. A permutation of an array of integers is an arrangement of its member into a sequence of linear order. For example, 1, 2, 3 means permutations for the following all are all the permutations of array 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. The next permutation of an array of integer is the next lexicologically greater permutation of its integer. What does that mean? First of all, by seeing the constraint, I can see that there is nothing like optimal solution. We need to just implement the uh, question. We don't have to do optimal and all. First of all, I don't understand what is next permutation. Permutation of an array of integers in an arrangement of its members. So the next permutation of an array of integers is the next lexicographically greater permutation of its integer. Okay, now I understand. So lexicography means if we have two array and we have to say which array comes first, which array comes after that. So like while naming, we see that we are giving names, we are sorting the student's name in alphabetical order. So if first letter of the two student name are same, like A, then you compare the next letter. Similarly here, if two here two arrays, let's say 1 2 3 is one array and 1 3 2 is one array. So we are comparing the first elements of the both array and they are same. So we now go to the second element, and the second element of the first array is 2 and the second element of the second array is 3. So 2 is less than 3. So the 1 2 3 array comes first and 1 3 2 array goes next. So that is what lexicographic arrangement means. So okay, so we have to find the next permutation. So now we have, so if 1 2 3 is there, what we can do is, wait, array length can be till 100, but in the test case example they have given only, Only three element they have given. Very nice test case. Hmm. Okay, so what algorithm are they using? I think we have to do it in O of n. They are telling in place and use only constant extra memory. So O of 1 is the space complexity. What do you? So we have 3, 2, 4, 7, 9. So now the next permutation, like if the array is sorted in the decreasing order, then there is no uh, then there is no next permutation. So the next permutation should be the array itself in the ascending order. So we have an array like this 2967. Okay. So then we have the next should not be like the next permutation should not start from the first place. It should start from the last place. That is my intuition. Okay, last place of the array because uh, because in the same two value at the front the array can have more permutation. Okay, and if the two values are same, then if you suddenly go to the three order, then you may miss some lexicographically similar kind of array permutations. So let's start from here. Here we have I at the last element of the array, and then we store it in some variable, and we go to the next element. And if that element is uh, larger, smaller than this element, then we swap. So 2976. then that would be the lexicographically next permutation. Probably. And if that, if the next element is smaller than the, if the like back previous element is bigger than this element, then we should go to the other, we should reduce the I and go to the previous element. And we see here, if 9 is smaller than, so the, okay. So let's see whether this works out or not. From the last element of the array, we need to compare that first we need to keep a pointer at the last element of the array, and we need to compare that pointer's element, the element of the index where the pointer is pointing, that element and the previous element we need to compare. If the previous element is smaller than this element, then we need to swap them. That's it. That is the next permutation. If not, we have to move the uh, this to the other element. And if we need to compare this to the previous element, if it is not small, if it is small, if the previous element is smaller than this element, then we need to swap, then it's finished. Or else we need to move to the other element. So like that. Okay, let's see here. So we have 2, 3, 1. So we are seeing here last element and previous last element we are comparing, but this element is bigger, so we cannot swap. So we are going here. And this element is smaller, so we are swapping. So it will be 3, 2, 1. Oh, wait. 3, 1, 2. Oh, 3, 1, 2 is also mm, wait a minute. The lexicographically next element in this order would probably be 2, 6, 7, 9. Right? Hmm. Like, okay, 2679 is our next, is our first element. We need to find the next lexicographical element means. mm, so I think this is problem is not this much easy. It's a little bit deep. So we have to think an algorithm. So then So I have 2679 as my array, and now I have s- like I know that the next permutation is never will never be the one where the first digit changes. Okay, because we have four digits, so we need to have permutations in between the next three digits. And if all the permutations of the next three digits completes, then only the two will increment to the other next smallest element like 6. Okay, so we have an array of 2679. So in that we have 2697, 2769, 2796, 2976, 2967. So these are all the things that will be the permutation having the 2 as the first element. And within these numbers only we will have our next permutation. And I think if we have given an array 2679, then 2697 would be the next permutation. So this is first one, second one. Then what is the next permutation of 2697? Um, so here, if you see 2769 will be the third one, and then 2796 will be the fourth one, and then 2967 will be the fifth one, and then 2976 will be the sixth one. So what is the algorithm behind them? On what basis we are telling this? So since the array of length is only 0 to 100 and the element value is between 0 to 100, we can use as much of time complexity as we want, like n square, n cube, whatever. But space complexity, they have strictly told it should be O of 1. So we should not use another array. And they told, yeah, in place they have told. So space complexity 1 means obviously it is in place. So, okay, I don't need to be worried about the time complexity right now. Time complexity analysis. I think they allowed 0 to 100, which means This problem cannot be solved at O of n. Probably. I don't know. Because if it can be solved with O of n, then why didn't they give, then they can as well give the number to be 1 million or something. So space time complexity probably will be optimal, maybe O n square. Okay, let's see the problem and then we will decide. Now, uh, see, if we have four integers, four elements in the array, until and unless all the rest of the elements in the array is sorted in descending order, then only we need to change the first element. Okay, I think the same will apply to the other elements also. So if you see the second element, until and unless these elements are sorted, this will not change. So if you see, 6 will only change to 7 if 9 and 7, these elements are sorted in descending order. Like 6 will change to the next highest element. So 6 will change to, so we know which number to change here. So because these two are sorted, 7, but 6 has to go somewhere. So what will happen? 6 will move there, 9 will move there. No, no, no. Yeah, 6 will move to the next element, and then all other elements except that will go forward. Okay, let's see here. So we see that only 9 is sorted. So we switch them. And if we see here, okay, let's see here. No. Now, if you see, these two elements are sorted. If they are sorted, like in if we are given 2796 as an question, we see the last two elements. In the last two elements, they are sorted 9 and 6 in the descending order. So it's time to change. So we know that it's time to change the previous element. That is the first indexed element. That is 7. In the 2796 array, we have to change the seventh element because the last two elements, which is 9 and 6, are sorted in descending order. Okay, but how will we go about it? We take the next smallest element after 7 in place of the 7, which is 9. The next smallest element, which is the greatest element in this case, so which is 9, we keep it in the place of 7. So, and then what we do is we move the 7 to the next place. Okay, and then we shift everything like that. Okay, so let's see. Okay, let's have a So let's have a 5 index array and then let's see what to do. You stay here. So let's say we have an array of, ouch, 3, 9, 6, 7, 5. Mhm. 2. Okay. Okay, now what we do, we compare last two elements. Yes, they are sorted in the descending order. So we will change the 6. We will change the 6 to its next largest element. Okay. If they are yes, then change the, if they are not sorted in the descending order, then swap them. That's it. Answer is over. That is the answer. If they are not sorted in the descending, if they are sorted in the descending order, then so we have to find an element that is greater than 6. But so here I am for the context, I'm having an array of 3, 9, 6, 7, 2. Okay. So since last two elements, 7 and 2 are in the descending order, we have to change the 6 to its next uh, smallest element. So we have the 7 as the next smallest element. But how do we find the next smallest element? Hmm. So we find the next smallest element through another iteration through the array. So we store 6. Oh, 1 second. I think we are stopping at the last two element. Whether we are only checking whether last element are in descending order. But what if last four elements are in descending order? So I think we have to loop from last to find the to find how much elements are in their descending order. Okay. So and we have to pick the element where where the descending order stops. Okay. So that is 6 here right now. Mm, so so we find the next smallest element. So how do we find the next smallest element? We will loop, we have 6 in our hand. We will store it in a variable. We loop through the whole array and then we will find the element that is larger than 6 and we will store it in another variable. Like we will have 0 in our hand. Then we will find the element that is greater than this, lesser than. We will find the element that is greater than 6 but lesser than the large element that we found. Okay, so we will first let the large element be 0 first. Okay, as we look through the array, if we are finding 9, so L is equal to 9, and then 6 will not count. And then we have to find some element that is larger than, sorry, that is smaller than, like we have to find an element that is larger than 6 and smaller than L and L is not equal to 0. Okay, so now if you see, first you put the first occurrence. Okay, wait, let's check whether this algorithm works or not. Then we will go to implementing the sub problems. Okay. Okay, so 7 is the second largest element. So what do we do is we put 7 in place of 6. And then what we would do is so we have two elements in our hand. So we may have as much as element in our hand. So what should we do is we have to place this 6. So we have to reverse the whole array. Okay. Wait. If you reverse the whole array, it will be probably 2 7. Reverse the whole subarray, and then we have to place our 6 in place of the 7. Understood? Okay. I'm not really sure whether this will work out or not, but it's fine. Let me try. Okay. But how do we find the next largest element? Okay, let's do in the brute force, most brute force thing possible. So for int I equal to 0, I is less than nums dot length I plus plus. I think I should be from nums dot nums minus 1. I is greater than 0. If I is equal to 0, then there is no way. Uh, so now we have to check. So we have to do I minus minus, sorry. So if nums I is greater than nums I minus 1, then we need to, oh shit, so if that is the case, pivot is equal to nums so we have stored the I. So till now, what information we have is that till which number we have. Uh, I actually think we don't need the value itself. We can just we just need the index. Yeah, pivot index. And after that, what we got to do is that uh, we have to find the next greatest number to 6. So we have to look through the whole array again. So the same syntax we will copy now and J. So what we have to do is, oh, okay, wait. They have told here itself that nums.i will be lesser than or equal to 100. So let's keep our largest num as, wait, int L large, next large is equal to 101. Okay, so now if uh, nums I should be greater than mm, greater than 6, greater than nums pivot index, and lesser than next large. I think this will not work. Ah, no, this will work. Wait, let me ask ChatGPT. Okay, so we cannot do that in Java. So what we do is we do AND operator. Hmm. Okay, so now logical. So what it does is it goes to 3 and then it sees whether 3 is lesser than 101. Yeah, but is it greater than 6? No. 9 is lesser than 110 but greater than 6. Yeah. Now, if this is true, then what do we do? Sorry. So, and 9 is less than 101 and then greater than 6. So, and this is not greater than 6. So, this will not leave. And then 7. is less than 9 and then greater than 6. Yeah. So at the end we will have next large as our 7th index. Okay. So what do we do is that, wait, actually, okay, now what do we do is that, uh, so we have the next largest index, and now our aim is to next in temp is equal to num. Mhm. Okay, sorry, we don't need temp actually. Uh, so nums pivot index is, is equal to next large and then nums next large index is equal to, oh, wait. Pivot index. This should come first.